Hello, audience. How are you guys doing? I hope we are live. You need to just confirm me in the chats. Say hello, say plus one, say anything, but we need to interact. I'll be waiting for your responses in the chats. You can say hello to me so that I know I'm completely finely audible and visible. Okay. Yes, I've gotten response from Pavan. I see you again. Yep. Hello, Pavan. Hello, Raghavi. Fine. All right. So, guys, let me tell you about the agenda of this session. We are going to be having, you might have already seen the title, we are going to be having a session on Machine Learning 101. Now, what is it? Well, it is yet again the part of Geek-O-Lympics. All right. So, we have been coming online and we have been conducting various quizzes, sessions. We have been giving prizes away. We are having specific giveaways, all as a part of our Geek-O-Lympics. Let me briefly tell you what Geek-O-Lympics is all about so that none of the people who are hearing it for the first time are going to miss the prizes, are going to miss the event. Let me share my screen to you guys. All right, people, this is the landing page of Geek-O-Lympics. What is it? Well, this is for the whole month. We are going to be coming up with new events. We are going to be coming up with new prizes and different quizzes with you guys. For you guys now, see, when I scroll down, you are having this events area where you have Code Extreme, Hack Wars, Geekster, Fun Zone, Live Stage, Job Arena, different things. In Code Stream, you can explore the event. You have POTDs, you have GFG Weekly, or you have God of Problems. So in this month of July, from 1st to 31st, if you are doing POTD regularly, you're going to be getting benefits. You're going to be getting some prizes. Same goes with the weekly. If you are doing it in this month, it is going to be even more special. So not just the goodies, but even more prizes. And if you talk about Hack Wars, this is a geekathon for you guys, Geekster. Similarly, we are having so many people coming here telling you about new things, telling you about how the things are going in the industry. Then we have Live Stage, then we have Fun Zone and the Job Arena, which is one of the most important things. We have mega jobathons lined up, right? So you guys should not miss it. The offer of the day is here. And one more thing, on some seldom days of this month, we are going to be having offers of the day. And these are the deals that you shouldn't miss. All right. Because you can see heavy discounts are being given, and these are just for days. And this is just happening in the month of Geek-O-Lympics. That is July, right? So for as a part of Geek-O-Lympics, today the event is Machine Learning 101. Now, this is, let me just stop sharing my screen. Yeah. So now see what is happening. This is yet one of the events, right? So many events have been already done. Many are about to come. You need to be very consistent and you need to get all the benefits out of Geek-O-Lympics. Okay. You need to make sure of your engagement. About today's events, we know machine learning is now become a trend, right? Everybody knows what machine learning is. But actually, do we really know the working? Or should we need to listen it from the expert? So for the same, we are having Sampoon Ratnjan. He holds experience of 8+ years in this industry, and currently he is working as a lead data scientist at Lumic, and all of his experience is going to be present in this session for you guys. So make sure you make all out of it, you completely understand what he's trying to say, and you have a very healthy discussion, because more questions you're going to ask, the more Sampoon is going to uh, cater those queries. So Sampoon, I'd be inviting Sampoon here. Sampoon, here is our audience. So
Hey, hi,
people,
Devashish. Hi, guys.
hello Sampoon. Sampoon will be taking over with the session. He'll be proceeding forward. Be interactive, ask your queries. The session is going to be very interesting. We are going to be knowing the industry insights, how it is working, what tools are required, what the things are going on. This is going to be really fun for you guys. So be attentive. I'll be taking off, and Sampoon would be continuing. Sampoon, the screen is yours.
Thank you. Thank you so much, Devashi.
Sure.
Let me just present my screen. Guys, I would like to know if you guys can see my screen. Just a second. Yeah. Let me know if you guys can see my screen. Yeah. So let's continue. So let's talk about machine learning. As Devashi said, it has become the one of the biggest, influential streams in computer engineering, right? Let's talk about it in let's talk about the basics of it in this session. However, I would just like to introduce myself, add to what Devashi said, right? In as part of my introduction. So, in the duration of my career of over 8.5 years, I've had I've had the opportunity to work on over 120 projects. They have been in the BFSI domain, in the healthcare domain, in the retail domain, in the edtech domain, the energy management domain, and even I've worked on national security. I've also had the opportunity to mentor a lot of people. I have mentored almost 80 people during those that time period, and I have seen the AIML space grow from its very nascent stage in 2015 to what it is now. It will go much ahead as well, but yeah. So one thing I would like to add is that I have intentionally ensured that my career growth has been T-shaped. What that means is that although I specialize in data science, but I have also worked as a data engineer. I also I am able to do DevOps really well, right? I am able to work for the full stack development as well. So I'll talk about what a full stack data scientist is in the session, right? But yeah, that's pretty much it about me. So the who is this session for? You know, people who have coded professionally at least once, people who who have worked or want to work with data, people who understand the basics of data analysis, even though they have no experience in machine learning, but they have some understanding of how to work in Excel, or how what data is, how does data analysis happen, right? So yeah. So there's this director of DARPA. It's the premier defense organization in the world, right? What he said was a very huge thing. He said machine learning is the next internet. As we all know, internet has revolutionized not just the our life, but the world as a whole. And people are saying that machine learning is going to take its place, right? So I have this very small problem for you. Can you predict the next number? Can you predict the pattern over here? I would like somebody to comment what is the next number. Yes, it is 16. Yes. What do you think will be the next number be? No, it's not 32, it's 31. Now what's next? It's 63.8. So, you know what machine learning does? Patterns which may seem illogical or counterintuitive to humans, machine learning algorithms can derive those patterns, derive those complex patterns, derive those complex rules, derive those seemingly impossible uh, uh, predictions, given enough time, resources, and data. I know this seems like a trick question, but the series is just a series of increasing positive integers. Yeah. So, but what is ML? How is it different from data science? How is it different from deep learning? How is it different from AI? These are a lot of terms, right? What these will be thrown at you at random in your professional life, and sometimes even in your personal life as well. But what you need to understand is this, that most of these terms, when layman people are talking about it, they use them quite interchangeably. However, all of them mostly mean the following, right? Earlier, in your traditional software development work, you had your input data, you had your business logic, and some compute will be placed, and you will get your output. Whereas in machine learning, you send your input data as well as your output data, you push it to your compute, and it will derive the business logic for you. How will this benefit anybody? Now, see, if you have this information, right, if you have your input and output data, and you can derive your business logic from those, right, that means that you will have an exhaustive set of business logic, right? And no matter what, no human can give you all possible cases, all possible edge scenarios, so all of these business logics cannot be covered by humans, right? So let's talk about the difference between deep learning, machine learning, AI, and data science. So I would just like to define machine learning. If ever somebody asks you what is machine learning, you just say this sentence. It's a very famous definition of machine learning. Machine learning has a lot of definitions, but machine learning is the semi automated extraction of knowledge from data. Now, what does this definition mean? Let's dissect it. Knowledge from data. So what that means is that you start with a question that might be answerable using data. Automated extraction. So a computer provides the insight. Now, it's not just automated extraction, it's semi-automated extractions. So what does that mean? Requires many smart decisions by a human. Yeah. So why do you think machine learning has, flourished in the past decade? There are a lot of reasons, but most of them come down to cost reductions and innovations. There has been massive cost reductions in data storage. I remember when we used to purchase 4 GB pen drives for 2,000 rupees, right? That was not 2 decades back, 3 decades back. That was 2010, right? There has been a cost reduction in processing power. Now every other laptop comes with the 16 GB RAM, and there have been massive innovations in the machine learning field. So just wanted to walk you guys through a very brief and 30,000 feet view of a brief of the history of machine learning. So it started with Alan Turing. He's said to be the father of computing, but what he did? He created something called the Turing test. With the introduction of chat gpt and stable diffusion and generative AI, a lot of people are now talking about Turing test. Now, a lot of people are now talking about, can some human differentiate whether the output generated by a machine learning model is actually by a human or by a machine, or by a machine? Has this art been created by a machine, or has this art been created by a human? Was this song created by a machine or a human? Is the player a person who's playing the game, or an entity who's playing a game? Is it a machine or a human, right? Now, Almost immediately after that, IBM's chief innovator, he created the first program to play checkers, right? It was a very simple program. You actually didn't play checkers, but you got to know what would be the next step. Now, what is the next? So, in 1957, the first neural network was created by the father of deep learning, Frank Rosenblatt. And now, after that, there was a huge gap. That gap is called the AI winter. That gap is basically because of something called that gap, that AI winter was ended basically because of something called back propagation. If we did get into deep learning, we'll talk about it. But yeah, the end of AI winter was initiated. Why? Because of, again, innovations in deep learning and machine learning, in cost reductions, in processing power and storage, right? Then then uh, so when the AI winter ended, people started creating these massive data sets. ImageNet was a collection of over 14 million images. Can you imagine? Even to this day, that data set is huge, and it was there 15 years ago, right? In 2016, Google's AlphaGo created shockwaves around the world by defeating the world champion. And in 2020, GPT advances were made. Gen AI has become the talk of the town in 2023, but the first GPT models were released in 2020. And just in 3-4 years, we have seen the progress, right? It was not, Gen AI was not in the news in 2020, but it made headlines in 2023, right? So let's talk about an application of AI or application of machine learning, right? There's this very common phrase in machine learning. It's called, there's a model for that, right? Whatever problem you have, whatever model you are trying to work with, whatever data you are trying to work with, there will be some work that has been done in that field, in that particular problem statement, in that particular section of life. So firstly, I would just like to talk about where machine learning has been applied in real world. And these are some of the examples that I have worked on. There are some examples that I have not worked on, but we have seen real world applications of these machine learning problem statements, right? So for example, in sales and marketing, it's you know completely driven by machine learning nowadays. Whether you go for churn prediction, what is churn prediction? Churn prediction is whether a customer will go away from you or not, right? Now, how to acquire the customer, whether a customer will become your whether a potential lead will actually become your customer or not, that is also between customer acquisition, lead scoring, right, and campaign optimization, right? Now, which product to sell to which customer segmentation, product recommendation, and even next best action. All of these things are basically used for identifying which product, which policy, which share to sell to which customer, right? Now, the throughout the customer life cycle, you will always see some model or the other, and this is not a complete list, but yeah, this is a very high level list, right? Now, whether we talk about operations, let's talk about operations, right? All of our country is built on logistics and operations. So whether so this is a very critical uh, domain in which you apply your machine learning. So predictive maintenance, inventory and demand optimization, manufacturing optimization, price recommendation, quality management, all of these are critical single points of failure within the operations domain that you talk about a lot, right? fraud and risk. So it's really popular. Machine learning is being utilized for uh, you know fraud and risk identification for in the BFSI sector. So so what happens is that if you the BFSI domain within India is quite developed, right? Uh, so however, with that development also comes the risk of fraud. That also becomes developed, and fraud and risk are ever evolving. It's reported that India loses almost $20 billion to fraud and risk within the BFSI domain. So whether that be fraud detection, identifying whether this person is going to pay the next EMI or not, should we give this person a loan or not, what is the probable EMI income this person has, whether this person has the ability to pay or the intent to pay, right? And yes, there are machine learning models that drive profit within the finance industry, whether that be cash flow forecasting, financial risk modeling, budgeting simulation, portfolio management, right? There are a lot more use cases uh, in HR and in other sectors as well, right? But let's move on to the next slide. Yeah. So these are some of the examples of ML problems, and these are some of the models that you might refer to when you're tackling these problems. Whether that be text to image generation, there's a very popular stable diffusion models, which, however, there is a premium version of that and there's a free version of that. But there are open source models such as Open Journey and Dreamlike, right? Whether that now if you want to do text classification, these are some of the model names that you should be aware of, right? Bert, Roberta, MNLI, right? Object detection, YOLO, V7, V5, all of these are performing really well. Real time object detection has been deployed multiple places, whether that be in our CCTV cameras or home security systems, right? ResNet and DETR, all of these are really popular, really common models that are being utilized to solve this problem, right? Music generation, there's a music, there's MIDI talk, there's music AIs, right? Gameplay, so TRPO hash, right? Agent 57. Now decision making, should I purchase this stock, should I hire this person, should I give a policy to this particular person or this particular applicant. There are models for that as well, right? Palm 2, STMNOE, HNN, these all of these models are again really popular and common models that they have solved this problem statement, and it's just a matter of applying this to your particular data set, right? Let's talk about the ML flow, right? How a machine learning flow actually works. So firstly, you need to do some sort of data collection, right? Then, after you have collected the data, you need to formulate your problem. Then you do a solution development, which has its own list of steps, right? I'll talk about them in a bit. After you have developed your solution, you need to do a solution validation, right? And then you do a phased rollout. You don't deploy your solution all at once. You might do some A/B testing or something called a canary deployment, where you deploy your solution for 10% of the cases. For the remaining 90%, it's still the same old thing, right? And then you would deploy 20, then 30, then 40, and so on and so forth, right? And then you do a continuous refinement as your model is going through more data. As it is seeing more data, you are collecting more data, and your problem formulation gets more refined, and you can develop a better solution, right? So all of this is a very cyclical iterative process, right? Now talking about solution development, you have your EDA, where you build your hypothesis and you validate it. You have you also define your output variable. You do your feature extraction and feature selection. You select your models and you evaluate them, and then you do the same all over again. Any questions over here? Okay. Now let's talk about some of the terms that you should be aware of, general terms that you should be, you should know when you're talking to someone within this field. So, firstly, let's talk about what are features, labels, and models, right? What are features? They are basically your input to your input to your model, your training data. So this is sometimes called an observation, and it's generally when you're looking at a tabular data, it's generally a row, right? And it's sometimes called a sample, sometimes called an example, instance, record, right? What are features? So features is your column in your tabular data. So it's your predictor, your attribute, your independent variable, your input, so on and so forth, right? Labels, what are your labels? So these are the target variables. This is what your model is predicting. Sometimes it will be called as target variable, dependent variable, outcome. But again, you should be aware that these are one and the same thing. This again would be a column. Just to reiterate, your features consist of rows and columns. Each row is an observation, and each column is a feature, right? And what is a model? It's just an instance of a machine learning algorithm that has been trained to recognize certain data type patterns, right? Any questions? Okay. So let's talk about the data splits. So your training data, what is your training data? It's generally 70% of your total data, right? It's used to train the machine learning algorithm. And one of the most critical thing is that it should be a representative sample of the population. What that means is that if your overall data set has, let's say, 80% females and 20% males, your training data should not have 40% females and 60% males, right? It needs to be a stratified it's this is called stratified sampling, right? This is basically you know you should have as close a data set, a training data set to the population as possible, right? Now what does that also mean when I say that it should be as close as possible? It means that your there should be as many data patterns within your training data set as possible that are available in your population or your entire data set, right? Um, Although I have not written it over here, but your population is your entire data set, and your sample is just a small selection of that data set, right? So, what is your validation data? It's 20% of the total data quantum. So, it has multiple uses. We'll talk about this in a bit more, right? So, validation data is most useful when you're doing something called k-fold cross validation, right? Uh, it is used for training improvements. For example, let's say if your training data has not seen enough variety, enough variance, you can use validation in data to infuse new data into the algorithm, right? And what is your test data? Finally, your test data is the 10% of your data that your model has never seen. It has never seen that. And the if your model has never seen that data, it becomes a final real world check to actually evaluate your ml algorithm. You need to know whether it was trained effectively or not. And if you do that with your validation data set, which has been part of your training data set, you cannot actually identify whether the real world data set is being able to be predicted on properly or not. So there are two major kinds of uh, machine learning, and I've tried. There are a lot of heavy, wordy, like lengthy definitions of each. But what I've done is I've just tried to summarize each of them in 4 words. So, what is supervised learning? It is making predictions using data. So, for example, is a email spam or ham? I don't know if you are aware of it, but it's slightly funny. But the opposite of spam mail is called ham mail, right? So in supervised learning, there is in supervised learning there is an outcome we are trying to predict. There is a target variable. There is a label that we are trying to predict, right? In unsupervised learning, you are trying to identify the pattern, the structure within the data. For example, segment grocery store shoppers into clusters that exhibit similar behavior. So maybe housewives will be a segment, maybe kids will be another segment who just buy the chocolates and toys and everything. Maybe young people who would buy the cheapest of things, and they in their college life they don't have that amount of money, right? No offense to anyone, right? But they can be a segment. But there is no right answer, you know. Whatever groupings are created, whatever clusters, segments are created, you have to run with it, right? You can obviously do an analysis, right? Do cluster your unsupervised learning again and again until and unless you are actually satisfied with the groups, right? So there are other kinds of learning as well. So reinforcement learning, semi supervised learning. Uh, so I think everybody is aware of reinforcement learning, or all the Tesla cars have it, right? Semi supervised learning is that, for example, if you have 100 rows of data out of which only 50 are labeled, you take you train your model on those 50 rows, right? 50 observations, and then you predict for those next 50, right? And then let's assume your accuracy in semi-supervised learning. You generally assume that your accuracy on the of your model is 100%, or you do a human in the loop effort to you do a manual intervention to correct the predictions of the remaining 50 wherever that model was wrong, and you update it accordingly, and then you retrain on the 100 labeled rows that you have now. Then there is something called transfer learning. And then there is something called transfer learning. So for example, uh, gen ai has a lot of use cases, right? For example, chat gpt was initially meant to be you know just a conversational chatbot. However, people have utilized it for other purposes as well. People have utilized it to identify the best stocks. People have identified it to utilized it to identify the best structures within a data set. People have utilized it to clean your data set, right? So then there is something called federated learning. Federated learning is nothing but when you have a huge amount of data set, you divide your data set into multiple servers. This is called sharding, right? And you basically train bit by bit, shard by shard. And there is something called 0 1 multi-shot learning, where model can just see a data once and identify the patterns. The model can see you know uh, the data just a few times and identify the patterns in new data from then on, right? And then there are models that are already available, so that don't need to be trained on any new data, and you already have those patterns recognized. So there are three phases in machine learning. And again, uh, Many people just focus on the first two, which is training and inference. But deployment is the most critical phase in my opinion, because if your model is not deployed properly, if it cannot be utilized properly, then your model is as good as useless, right? So but let's talk about the training process. So I know we have had a proper discussion around this, but yeah, training in simple terms. Again, I've not tried to go into the definition of the word or the term, but I've tried to simplify the word into simple English, right? It's the process to learn and optimize a model from data, right? So, for example, let's say there is a model called XGBoost, right? When you train, your training output is an instance of XGBoost, right? Yeah. So inference is basically nothing but estimating outcome from new observations. And we use the trained model in the previous step to estimate or predict outcome on new observations, right? And deployment, you have to expose your models such that predictions can be made at scale and in a secure manner. That in itself is a field, it's a branch of data science called MLOps. It's a huge branch in itself, right? And you should understand it is the most critical. It is this is at this point main almost. So there's this statistic that almost 90% models fail simply because they are not scalable or they are not utilizable by a business. And this is the place where most models fail, your deployments, right? So never forget that there are not two but three phases of machine learning: training, inference, and deployment. Yeah. Uh, so feature engineering is again another term that you must be aware of. There a lot of people will talk to you about it. Feature extraction is nothing but transforming. So for example, if you have, let's say, 100 features, right, and your model will not be able to utilize every single one of them because not all are useful, or some are related in a way that their combination makes them useful, right? Feature extraction can combine the original features into a new set of features, right? These are more informative and more compact. The goal of feature engineering is to capture all possible essential information, right, without uh, whilst at the same time reducing the overall problem statement to a lower dimensional space, right? So instead of 100 columns, you might have just 10 columns, right? Feature selection is quite simple. You actually just select a small set of relevant features from the original set of features. Both feature selection and feature extraction have the same end goal, that is reducing the dimensionality, right? However, uh, feature selection does not create any new features, whereas does not create any feature extraction does create any new features, whilst it may or may not retain the old features at all, right? So I just saw a question that what are some project topics, right? I would just like to reiterate that just a few slides ago, I just talked about some of the project real world applications, and then real world machine learning examples which you can take up to as your practice problem statements, right? Whether that be your churn prediction, whether that be your lead scoring, you have to go to Kaggle, you have to go to Geeks for Geeks, and get the adequate data sets for these problem statements, and you will have a problem statement. If you can do any of these, right, your resume is perfect then. So, so the issue is that there are so many models, right? uh, all it's said that the age when everybody anyone can know everything about data science has is gone almost 10 years ago. And just the simple machine learning models, there are so many, whether that be for classification, regression, clustering, and dimensionality reduction. So I have just taken up the sheet from a Python library called scikit-learn. It is one of the most popular libraries for machine learning models, right? And we have talked a lot about how to choose which model. So if you have less than 50 samples, you need to collect more data. If you have greater than 50 samples and you're predicting a category, and if you have labeled data, then maybe you are doing a classification problem, and then you can choose which model to take on the basis of the data set that you have, or whether it is a text data or not, right? And if you are trying to do, if it is not a labeled data, right, then you might go for clustering, and then it's simply a problem statement of the amount of data that you have. If you don't have enough data, then again, tough luck, you have to collect more data, right? With now If you're trying to create a predictor with less than 100k data points, less than 100k data points, right? So maybe you do something called an SGD regressor, or you do something called a lasso or elastic net regression, right? You Again, these are L1 L2 regressions that everybody should be aware of, right? And if you have a lot of data set, and you need to reduce your feature space, like some sort of feature extraction, right? You do a PCA, or you do something called a kernel approximation, right? So uh, so project ideas, again, just to reiterate, somebody is saying that I need major project ideas. Text to image is again a basic one. I would just like to reiterate, in my field, I have taken a lot of interviews. What I would like to say is that I don't see if a person has solved a technical problem statement. I see whether a person has solved a business problem statement. A person has been able to convert a business problem statement to a technical problem statement, and then being able to solve it. I would like you all to go back to that, just some real world applications of those data sets of machine learning, right? Again, I would like you to pick up the first one. Churn prediction is one of the easiest ones. It's again a very you common problem statement that companies are facing even now in real life. If you don't want to do churn prediction, maybe customer segmentation or product recommendation might be of interest to you, right? And so this is machine learning 101. LLMs, somebody is asking, can you talk about LLMs? Those who do not know, LLMs are large language models. They are a type of generative AI. This is not within the scope of this machine, this particular session. But if you would like to talk more about it, I am more than available, right, after this session. Somebody is talking about how should I handle missing or corrupted data in a data set, right? So there are very very common strategies you can take. Again, it depends whether that the data point that you are trying to. So this is called imputation. You need to, when you are handling uh, you know uh, missing data set, the most common approach is called imputation, right? Now, if it is a categorical data, so for example, some it's a column called gender, and male female missing, male female missing, things like that are happening, then you can take the most common or most frequent value. Or if you are taking if it is a number, for example age, then maybe you can do a mean median mode kind of a thing, right? So these are some of the most common ways. However, there are again, go through scikit-learn, you will find a lot of ready-made imputators for you, right? You would just need to pass the data and it will do the job of imputation for you. So somebody is asking, is it a must to learn TensorFlow? So to be very honest, if it was 3 years ago, I would have said yes. Nowadays, it's not. PyTorch and Keras are wrappers on top of TensorFlow. That if you just learn those two, you might not need to learn TensorFlow, right? So coming back to the presentation, uh, these are the main questions that you will always be asking, no matter the problem statement. So, how do I choose which attributes, features of my data to include in the model? How do I choose which model to use? How do I optimize this model for best performance? Basically, which model parameters would be the best? How do I ensure that I'm building a model that will generalize to unseen data? That is, which metric to evaluate your model on, right? And again, uh, the I don't know if this deck will be available to you guys later on. Definitely, this YouTube link will be. However, if you guys want to take a screenshot of this, this is the most important slide of the entire deck, right? You should always ask these 4 questions before you are tackling any problem statement, right? Which attributes, which model, which model parameters, and which model evaluators, right? So there's this very popular saying in English, and I'm not now going to talk about which tools you can use, but there's this very popular saying in English: "Do not draw your sword to kill a fly." If I can just speak in Hindi, so there's this in Hindi. There's a muhavra: "सुई का काम तलवार से नहीं करना चाहिए." Right? So do not draw your sword to kill a fly. Know what tool to use when, right? So we are just going to talk about that in a bit. So, so these are the tools available to a data scientist, and damn, that's a lot, right? And this is not the whole universe. This is like a very small section of the most, and these are the most popular tools, right? However, what I have done is I've taken a very small set that you need to choose, right? So, for example, you should know Git. You should be able to work on Linux. You should know what is PEP 8, what are best practices for creating code, right? Whenever you're writing a code, what are the best practices? You should be able to wrap your model in a fast API. You should know what Docker is, right? And again, this again seems like a lot, but this is much less than the previous slide, right? So uh, Postgres, MongoDB, again, you should be aware of these things. If you know Postgres, you know SQL databases. If you know MongoDB, you know NoSQL databases, right? There are other database paradigms such as key value, vector DB, things like that. But these are the two most common, most popularly used databases, right? In data visualization, so a very huge mistake that newbies generally tend to do is try to use Python or R to visualize their charts, whereas Excel can create those charts in 10 seconds. What it will take 1 hour for you. And a lot of people think that this feels like cheating, but the ultimate goal is to provide the output, right? Whether that be in Pandas, Python, Seaborn, or Excel, right? In machine learning, uh, uh, you know there you need to know Python, you need to know sklearn, you need to know PyTorch, and you might not need to know Keras, but the thing is you should know either PyTorch or Keras for deep learning. So somebody has asked, what is deep learning? Deep learning is uh, any kind of learning that ultimately uses the neural network, right? And what is a neural network, we can again talk about it in a later session. But yeah, this is machine learning 101, right? So yeah, something called data and model versioning, you need something called DVC. So you will do a lot of iterations. If you remember that machine learning is an iterative process, right? And when you are doing one experiment, you don't want to, when you are doing one iteration and then you move on to the next, you don't want to lose your results, or you don't want to not save your model, right? So that is why DVC is really important, and DVC with ML flow is really really powerful, right? And you should be aware of either AWS. You should know what is an EC2, what is S3, things like that, what is SageMaker, things like that you should be aware of for GCP or Azure as well. So CSP is cloud service provider, right? Now, as I was saying, deployment is a huge, huge field in data science. It's called by its own name, MLOps. And a lot of people might not take it up, but again, you should be at least aware that for deployment, there is things like Kubernetes, Terraform, and Jenkins, right? So that's just a lot of, you know, these are so many things, right? So what I have done is I have taken a very small example just to help you guys think, see that actually machine learning can be quite simple if you just know how to work with it. So this is an example of supervised learning. I am playing with the iris dataset. This is the general supervised learning flow, right? You have your training data, you create your feature vectors from it, you have your labels, you push it to the machine learning algorithm, right? And you get a predictive model instance. Again, machine learning algorithm is an XGBoost, whereas what when you do your training, the output is an instance of XGBoost, right? Whenever a new data comes, you convert it's to its feature vector, and then you use the model instance to create a predicted label. I moved really fast, but let's see how much of it you understand. Now, let's talk about the problem statement, the supervised learning problem statement. So there's this iris flower, and a long time ago, somebody saw that, so there are certain species of iris that they have their heights and widths. There are specific heights and widths that the iris flower family follows, right? So what does that mean? Within the iris flower family, there is a species called uh, virginica, right? So they might, their height and width of the petal, the height of and width of the sepal might lie within a particular range. But nobody is going to measure all the flowers in the world, all the iris flowers in the world, and identify that range. But machine learning can do that for us, right? So DVC means data version control, right? And so just to, somebody has written, I'm sorry, I have to take this question. Somebody has written that they have scored less than 60% in my 12th, and you are not eligible in any company. It feels like dead end of my life. That is just it. So you know take some time, it will pass. And I would recommend that you take some time. This feeling will pass, and during that time you build your resume, you take up those projects I'm talking about. If your project is strong, you don't need to actually go through college placements where the companies, they don't want to interview hundreds of candidates, so they place artificial filters, right? So maybe you can apply to companies one at a time, and if they see your resume, if they see what work you have done, what blogs you have written, what is your GitHub like, what is your LinkedIn like, right? then you will have a job very quickly. So don't worry about the score you made in uh, 12th, but that doesn't mean that you can relax now. You will have to work much harder because of it. So yeah, let's look at some code. So the iris dataset is so popular that sklearn has published it within its own datasets, right? So all you need to do is import a function called load iris, right? And it gives you a thing called bunch, right? Again, you don't need to get into the depth of it, but if you print the iris data set, you will have the height of the petal, the width of the petal, the height of the sepal, and the width of the sepal, right? So just wanted to show you. So this is a numpy array, and you have 150 rows with 4 columns. So first dimension is the number of observation or the number of rows, and the second is the number of labels, the number of features, right? And so, oh sorry, I think I switched the sepal length and petal length, but yeah. So the so as you saw in the previous slide, this is actually sepal length. So 5.8 centimeter is the sepal length, 2.6 centimeter is the sepal width, 4.0 4.0, this is 4.0, right? This is just Python's way of representing 4.0. Don't get confused by it, right? 4.0 is petal length, and then 1.2 is petal width. So these are my features, right? Sepal length, sepal width, petal length, and petal width. So I have these 4 features. There are 150 observations. Let's have a look at the target or the label. So our target is divided into 3 numbers, 0, 1, and 2, right? And there are 150 target values. But if I wanted to get the names of the targets, that is also available, right? Setosa, versicolor, and virginica. I'm probably, mispronouncing them, but that's all right, right? So I just wanted to show you the 4-step process. All you need to do is import the class you plan to use, whether that be k neighbors, k means, or anything. You just do a k, you instantiate the estimator, or you create an instance of the machine learning model, right? Estimator is sklearn's speak for model. Instantiate means make an instance of, right? And then you fit the model with the data. That is, you do the model training, right? Then you predict for a new observation. That's it. You're done in less than 10 lines of code. You can predict multiple observations. I hope this is visible to everybody, but yeah, if it's not, let me just show you another one. So instead of the k neighbors, what I'm going to do is take up logistic regression. Again, another classifier, another model class that I have to import. Then I have to instantiate the model. Don't worry about the parameters as of now. Whenever you are actually creating such a model, obviously you will have to google the parameters. There are so many parameters to each classifier, nobody can remember them, so you will have to google each time, right? So don't worry about the parameters. I had to Google this before I wrote this code, right? So you instantiate the model, right? You fit, and then you predict. Again, one, two, three, four lines of code, right? In 4 lines of code, you can solve a simple machine learning problem. This is not to say that every problem statement will be solved with 4 lines of code, but I'm just trying to say that how easy it is to start, how easy it is to begin your machine learning journey. So, yeah, thanks. I guess if you have any questions, please, now is the time to comment, I guess. And Devashish, if you're there. So I'll just stop sharing and have a look at the code, at some of the questions, right? So data structures might not be as important in machine learning, but again, you should be aware of what is an array, what is a list, right? But maybe you don't need to know about a doubly linked list. You know, you don't need to know about FIFO or things like that. But yeah, basics should be clear. uh, DVC means data version control. Again, it is used to manage your data, manage your models. Image processing versus computer vision, and CNN, please. Can you explain in brief? So, computer vision is a domain, and one of the steps in it is image processing, right? You don't actually just, process an image, you do something with that image, right? So that again comes in computer vision. CNN again, I would like to take it up in a later exercise, right? And again, it's one of the core deep learning algorithms, right? Or it works functions mostly on images, right? And that's pretty much it. There are it's someone How do we start with the learning in the domain of AIML? Okay, the difference between data engineering and data analysis. Data engineering is mostly, you move data, you transform it, and then you make it available effectively, right? Data analysis, you derive insights from the data. How do we start the learning AIML? Like I said, you should start with software engineering. That then you should learn basics of Git, Linux, and best coding practices. Then you should start with maybe some database learning, Postgres, MongoDB, then Pandas, and then Seaborn, then sklearn, and then finally go on to your deep learning journey, right? So there are how we can increase HR productivity with AI/ML. So basically, one of the most uh, critical issue of HR is bad hires. So how do you optimize for recruitment? How do you uh, maintain your employees, right? Your employee retention. There can be algorithms made that can identify that, okay, this employee might stay back, this employee might not stay back. So maybe that's a way you can look at it. If someone is interested in both DSA and ML and data science, which path should you prefer? I cannot say that for you, Snehashish. You will have to make a decision. Have taking both those paths is like close to impossible, because both those paths are quite massive, right? uh, so how do I switch from to AIML after learning J2EE? I have an option of data engineering with Java. uh, so again, switching becomes much more easier for you, because you know the basics of uh, software engineering. You know what is Git, you know what is Linux, you know what is Java, when how do you write the best code. However, what you should start with, you should start with Pandas. You should take up a 2-hour workshop of Excel. It will be available on Geeks4Geeks or YouTube, right? And only then you should take up sklearn. And then after that, so just to reiterate, Pandas, sklearn, and then deep learning, right? What about JavaScript AIML? Any insights on this? Kindly share your views. Venkatesh, thank you for this question. I don't. So this is going to be the future of data science, which is basically, instead of having a server side model, you can deploy a model in the client side, which is the Chrome extension or things like that. So yeah, ultimately JavaScript will be utilized very heavily with AIML. But yeah, eh, is machine learning has predefined packages? Sklearn is one of the best packages for machine learning that you can take up. Got it. But what about Python and JavaScript? AI? Well, so okay, so there are two ways to it. You either take the Python route or the JavaScript route. Python route is more common right now. JavaScript route is still nascent. You can take it up, but you will see a lot of challenges in getting relevant jobs for it. But yeah, in my opinion, maybe 2 or 3 years from now, instead of having a huge server, right, where your very huge model is deployed, the maybe 3 or 5 years from now, we will have very small servers that will be pulled into Chrome itself, right? And that is where JavaScript will be used. But again, it's the future. Right now, I would recommend go with Python. Okay. Any more questions? What is semi-supervised machine learning? I talked about this in the session. Semi-supervised machine learning is you have let's say 100 rows of data. 60 are labeled, 40 are unlabeled. On the basis of those 60, you train a model, you predict on those 40. If let's say you get a 80% accuracy, you don't actually have to, or even if you get a 50% accuracy, right, you don't have to annotate all 40. Now you need to annotate just 20, right? So semi supervised machine learning, if you remember the machine learning definition that I gave, it a machine learning is semi automated. That is why semi word is really critical, because humans have to give input there, right? So humans have to annotate on their own accord. So that is why semi supervised. Right, any more questions? Sort of, what question did I not respond to? Gap after 12th count in a I'm sorry, sort of, is gap after 12th count in academic gap if someone done BTech after gap? Uh, I don't think a gap matters after 12th. Again, just to reiterate, if your resume is good, if the projects that you have done are good, your marks won't matter. But again, your projects have to be numerous, maybe at least 10 such projects, and then the projects have to be meaningful. They don't have to be like text to image. They have to be a problem statement, a business problem statement that you solved, right? uh, So, is it wise to enter competitive programming during this dawn of AI age where top companies are discontinuing their coding competitions? I cannot talk about that because, uh, I don't know. This is, highly, it's a topic of huge debate, right? I'm sorry, I cannot answer that right now. So, yeah, I think that's pretty much it. I think all the questions are answered. I think I'll ask Devashish to end the stream. If there are any other questions, please let me know. And again, my name is quite uncommon. You can find me on Google itself, right? So, yeah, okay. Thank you, guys.